So yeah, so I'm Nicolai, Java developer advocate for Oracle. We already covered all that. About the language. So, what versions are you guys on? Just out of curiosity. So let's say, I'm only asking about the newest version you run in production. So for whom is the newest version Java 8? Wait, you are running Java in production, yes? You're not like, it doesn't come out like everybody's like, no, I'm actually running just Node and Kotlin. No? Good, okay. So who runs Java 8 as the newest version in production? Nothing new in Java? Yes, great. Okay, so what about 11? 17? 21? That's everybody. Okay, so who thinks about 24? Anybody on 24? Yay. Oh, that's really cool. I appreciate that. That's way more people than usually. Like even in much larger audiences, I don't usually get 3 people to run on the latest build. Okay, so I guess then, since you are here and you're all running 20, well, a lot of you are running 21, that you're interested in running 25 soon-ish. Yeah? Okay, so it's good, then we can go talk about these features. So, I do focus on 25, but we have a little bit of backlog. We have a little bit of a break in between, right? And then we can talk about the features that came in earlier versions as well, in 22 to 24. I cannot go into a lot of detail on all of these features. Even though if you do have questions, we can probably go deeper, but there's only so much I want to put on the slides. The Java YouTube channel has more, and you can already see the slides online if you wanna, but I will also send a link out later with exactly these slides. And then you can look at those. And yes, you can ask questions anytime, right? Like, don't wait for me to take a break. That doesn't happen very often. Just raise your hand and go. Okay, so the list of final features in Java 25 is kind of long-ish. Module imports, simplified main, flexible constructor bodies, scoped values. All of those have been in previews and are final now. Ahead of time, method profiling and easier command line interaction is there as well. JFR has seen some improvements, and then we have compact object headers now as well. And then there's more. This is stuff that has been finalized in Java 24. We're not going to go through all of, you don't have to memorize the list. 23 was a little bit slimmer, but this is only final features, right? 23 had a bunch of previews that were finalized later. And then 22 had unnamed patterns, foreign function memory API, multi-source file programs. So, then we also have a bunch of preview features that are in the JDK. String templates no longer part of that. There used to be a preview feature in 21, 22 or something, and then it dropped off the map. We can talk about that as well, actually. And then a bunch of others that are in preview. And basically, we can talk about all of what I just showed you. But the goal here is to focus on 25. So we're going to pick those 5. We're going to talk about those in a little bit more detail. And then we can see after that what else we can pick and choose. Okay, ready? Let's go. Wait, there you go. Immediately made a mistake. Okay, so, right, because the slide deck is 2-dimensional, in my defense, that's, oh, you can't see. Okay, anyway, like wait, I can show you though. It is, like, trust me. See, there you go. It is 2-dimensional, actually. Okay, so, who uses star imports? Who prefers star imports? One person? And the rest, 2 people even. Okay, and the rest probably more on the option A camp, I take it? That's common, like it's usually like 80-20, maybe 75-25, preferring the first list of kinds of imports. Okay, so star imports, as I will call them, option B, has a few upsides. The reason why people like to use them is because they're more succinct, right? You can just more easily actually see the imports, because if the imports are very detailed, let's be honest, nobody actually looks at them. And they're easier to manage manually. And the downside, it's less clear. There's a certain chance of conflicts. Within the JDK, the chance is actually surprisingly slim, but if you import from different libraries, it increases rapidly. And the other part is it's kind of can be a weird slice through an API. Sometimes a package contains like a full API, but sometimes an API is split across several packages, and star importing one of those packages means you just get like, I don't know, like a weird half of whatever of the API. So for those who are interested in star imports, may introduce you to module imports. Very important, maybe it's the second point, your code does not to be in a module. So don't just shut off because, oh yeah, modules, we don't use those. You do use modules if you're on Java 21 because the runtime you're running on is a module. It's not a module, it's modularized. It's split to several modules. And whatever is a module, be it JDK module, your dependencies, or your own code, you can import module and then the name of that module. And here it says imports the public API of that module. We can actually go into a little bit more detail. First and foremost, it imports all public top-level types in packages that are exported by that module. So if you ever heard about modules, right, you probably know that you can write like an export statement. So all the packages that are exported, and all the public types therein, those are the ones you can definitely read and access. And those is like the majority and the most important ones. And then there are 2 more detailed points for those of you who do know modules a little bit better. That is, if a package is exported to just your module, then you can also read all of those types. And then if you depend on a package, which transitively depends on another package, and pulls that in and exposes that through implied readability, then you can also read that. But the summary is the public API of that module is what you can read. So I would say, compared to the regular detailed imports, it's even more succinct. It's trivial to manage manually. It is still less detailed, of course, than the individual imports. And that makes conflicts a little bit more likely, but you will see that the point that is no longer on the list here is it's an arbitrary slice of an API. I'll come back to that in a second. Let's first talk about conflicts. So here I did my best to have, like, I think both conflicts that are even possible, which is the list type exists as an AWT list and as a Java util list, and then date exists as a Java util date and then also as a Java SQL date. And so both of those references to date and to list are now ambiguous, and you resolve those just like you would if you have star imports. You just place the more explicit import there as well, and then it is clear which one of those it's meant, and then it works. All that said, I don't know, don't use date, I guess, and probably also don't use AWT list, so I don't know. But still. Consider using module imports when you're already using star imports. Everybody who's using star imports, I think, should see this as just a clear upgrade. It comes with all the advantages and with few of the downsides. And also, if you are occasionally writing scripts for automating something on your system, or to show something to a colleague, or to experiment with something, in those circumstances, it's just really handy. Just write like, yeah, import module Java XML, if you would want to handle that, if you want to deal with XML, for example, or Java SQL maybe. And then you just have the whole package, the whole module and all the packages it contains. Makes it very straightforward. Okay, I've used them because I do write a lot of the letter here. I started to use them a bunch more. And I don't know, I'm starting to think maybe I should use them in real life production code too. And I was definitely in camp of option A. Like I thought, like people who use star imports just want to see the world burn. Why would you want to do that? Use detailed imports. But now I'm kind of coming around, I'm not sure. Like this is just really straightforward and easy to use. Okay, so this we're going to come back to in a second because this connects to another topic that we're also going to talk about, so ignore this. If you want to learn more, Java JDK enhancement proposal 511 was the one that finalized this, that contains a lot of information, and then usually we also made a video about it. So if you get the slides later and you're interested, you can just go and look at some of the follow-up sources if you want to. Does that make sense? Should we go on? Okay, let's talk a little bit about Java simplified main and the on-ramp. So there's a specific feature that was finalized in 25, but there's also like the bigger picture, and we're talking about the bigger picture here. We'll see in a second. So generally speaking, Java has a very mature ecosystem and community, right? It has a very refined program model with visibility modifiers and all kinds of like stuff like final, lots of help with concurrency. It's a very detailed tool chain where you have different tools for compiling and then for packaging. That could be jar, or it could also be JPackage, or it could be JLink. All of those do some kind of packaging. And then clearly you have to run with the Java binary. You can start to include build tools in that. And it's a very rich ecosystem where starting with build tools, but also actually starting with JDKs probably, but then also build tools or testing frameworks or web servers, you have a lot of choice. And this is great for people who use this ecosystem professionally, but it's not ideal for beginners. For a beginner, just going to openjdk.org and looking for a JDK to download, for example, already makes things a bit complicated. When people are like, okay, so what do I do? And you say like, well, okay, for that Unity dependency, may I introduce you to Maven/Gradle/Bazel? That's not really great for a beginner, right? So this level of detail is great for us. It's not that great for a beginner. But I would argue that Java does need to stay approachable for kids. Like, like my daughter over there, maybe at one point she wants to program, and do you want to do a banking app? It's maybe not the greatest place to get her started. Definitely students do still learn Java in school, and we hope it stays that well in university. Front-end developers, the machine learning, AI folks, or whoever else already knows programming and comes over to Java would also benefit from something that is a little bit more straightforward. So I think Java does need an on-ramp for new Java developers, either for people who are entirely new to development, or also for people who are already developers but want to switch to Java. And the idea here is that to have an on-ramp, an on-ramp from, where beginners are to the highway of all Java features, basically. And the on-ramp part that I'm going to discuss with you here are these three parts. These are by no means all of them. A lot of the things that I just discussed, like dependencies or building, for example, is not really addressed by this. Like, why are there so many different JDKs? It's not addressed by this. So this is just, this part of the on-ramp concerns itself with early stages of learning the language and of running a program. And the idea here is to make code simpler by just simplifying the amount of concepts a beginner has to learn. So instead of having public static void main string bracket args in its own public class, we remove basically all of those requirements. The args parameter array is not needed. Main doesn't need to be static or public. The entire class itself can actually be elided. Just void main and then whatever store print line, or now we have actually IO. I'm going to show you in the next slide. This is not an excerpt of a larger class that runs. This runs on its own as it is, which makes it much simpler to get started. And finally, all the JavaScript people can stop making fun of us because of our lengthy main methods. That hurt me personally a lot that they did that. Okay. Also, system output. Oh, by the way, I didn't even mention that. The reason why we leave these things out is not only because there's a lot of stuff there that you have to put there, but it's also a lot of concepts for the beginner that they either have to learn or have to ignore. And both of those are really not great situations, right? So they are curious and want to like, so what does static mean? And then you have two choices. You either tell them like, no, don't be curious. Like, learn what I tell you, but don't ask me questions. Or the other way, you can be nicer about it, I guess, but still. And the other one is explain what static means, which is daunting. Imagine talking to somebody who's not programmed before, who doesn't even really know what object-oriented programming is. And then you have to explain to them all of object-oriented programming to then come back to, but if you don't want to do that, you use static. This is clearly not ideal in a learning situation. And also system out is great because system out is really weird. Like, so what is out? Well, that's a public field, public static field, actually, I should say. But please don't ever do this, but you have to use it, but don't do it yourself. So now we have a class called IO, which has methods like a print and print line, and read line also kind of nice. It just says print this prompt to the screen and then read the rest from the terminal without complicated open an input stream and then put that stream into a buffered stream or whatever. Just go IO read line text, and then this prints that text and waits for the user to type something, hit enter, and then it ends up in this variable. So also very straightforward. There was an intermediate proposal where you would not have to type io.println, where println would have been statically imported, but that was abandoned. So IO is now just a class in JavaLang, and all classes in JavaLang are available without imports. So you have to write io.readline instead of just readline, which I think is better, even though it is a few more letters, because it doesn't start with something that very soon turns out to be also magic. Because where does the read line come from? Because all other methods, sooner or later, we want them to write other methods, right? So all the other methods are in the same file. You just call the method by name, right? But that makes read line look like it's also in that file, but it isn't. So I think this is more well structured. Okay, now we're coming back to this that I skipped a second ago. What I'm doing here is I have basically a very complicated hello world that just uses a bunch of different things like lists and big decimal and local date and random generator and all of that. The interesting thing is that this simplified class, this simple main class that does not have a class wrapper, it just has the main method, gets for free import module Java base. So that means you can just get started with the most basic types and you don't need to have to add imports for that, which I think is also pretty handy. Okay, so that means that from a language perspective, the starting point is a little bit simpler. You don't need to learn all about these concepts or ignore all of these concepts. You can pretty quickly start with, this is what a method is, and now let's write some statements that do stuff. You can execute this really easily with just throwing it at the Java launcher. I don't recall right now what Java version that was in, but it was a while ago, a couple years. I think maybe 16, 17, 18 or something. So that's been around for a while. What is new now, which was added between 21 and 25, is that if main.java references other code, then the Java launcher will try to look that up. So if main.java mentions a helper class, like the Java class, it will assume like, wait, okay, maybe there's a helper.java file next to main.java. Let me see if it's there. And if it's there and has like public class helper, or even just class helper, then it works. But if you mention in main support.java, it would look for support.java the file and wouldn't find it, and then you would just get the error that you expect. Also, you can, if you want to, dump some jars into library folder, and then you can put that on the class path. And all of that you can just throw at the launcher. No compilation step, no separate launch step. You just say, Java, please launch this little project. And it tries to be smart about where to find classes.
Does it support block expansion in the class path? Like the nested structure of the libraries? Is there support for this block expansion, I think it's called?
What do you mean, what one?
Block expansion. So if you just put a directory name and the double star, I think, then it would automatically
No, I think that Java by default doesn't support that. That was not changed. So this is the same broken-ish stuff with the where you only have to put the quotation marks, because otherwise I think the terminal expands this and then it doesn't work with Java. So that everything you have to do regularly with class path, you still have to do here.
Okay, cool.
Okay, so that means that you can write little programs, even with dependencies, although the question mark here remains, where did you get library.jar from? I mean, it has 0 other dependencies. Maybe you could download it from a project page or go to Maven yourself. But if you start having actual dependencies with actual transitive dependencies, like it's nice that you can do this, but it's very questionable, like where do you get the jar from? And this is also basically unsolved at the moment. Okay, so this gives it a natural progression though. You can start with just main and let people start writing their first code with just understanding what statements and expressions are. And then if you want to pipe in arguments from the terminal, right? Maybe they want to write a little bit of a command line tool, introduce them to the string array. If the method becomes too unwieldy, how to declare your own methods. Then you can have fields in that if you want to. I would probably be careful with this because this makes it easy for spaghetti code, right? Then you can put one method, can put something into a field, another method reads it later. But yes, you can totally have that if you want to. If they need more functionality, JDK APIs are there. Many of them are in Java base. All the data structures, for example, are there. Everything deals with dates and times, which is probably something that you might see on your own system a lot. So that's all there within the base module, which you get the import for free. But then if you want to do SQL, for example, import module Java SQL, and everything is there. If you have simple libraries that they need, and you can provide for them, you can just put them in the folder. You can split this into multiple files, as I just showed you. What I did not show you is that you can also use visibility and packages and modules. That all works. Like you can have a module for Java in there. And then you can do, instead of class path, you can use the module path, which is smarter about all of this. So that's an upside. And it will do the same thing, right? Like it will basically assume that the folder you start in is the root source directory of what otherwise would be your project, right? So something like, in most cases, that's source main Java, right? It basically acts as if you started the Java process in source main Java, meaning if you use a class in a certain package, it assumes that, well, every segment of the package name is probably its own folder, and then I go in there and look for it there. Note, which not everybody knows, this is not at all demanded by the Java compiler, right? The Java compiler doesn't care. You can have, like, just for fun, on the next project, copy all the Java source files into the root folder. Leave the package names, leave like the declarations at the top of the file as us. Just copy them and compile them, and it will work. The compiler does not care about this whole nested package structure that we use for organization because we like it better. But this Java launcher does care because it needs to know where to find the Java class. So it looks into these folders, and if it finds it, it's all good. And the best thing about this, it doesn't have to be that order, right? If most of those things can be switched around. If, for example, piping arguments in is not something that your demo needs, then skip this step, right? Or it's not even a step, it's just an option that you have when you teach to somebody. I have a whole talk that goes a little bit deeper and describes more about what APIs maybe to use with beginners, and then also what some of the weak points that remain are. For example, where do you get jars from? That's still a big one. And so yeah, I hope that this, also how to teach programming concepts. I think, as I learned in university, and probably most of us who studied computer science learned, is maybe not the approach that is best for teaching Java the language, which is, let's start with like a very general construct, and then let's start from the ground up. Let's start with class. What is a class, and what are all the details of a class? And then later talk about other things. I would, for example, start with records. In this spirit, I would be like, oh, you need a simple data holder? Here's how you write a record. And then maybe later we get around to, oh, a record is actually just a special form of the general construct. The general construct is a class. And go from something usable and simple to something more general afterwards. I think that's a better way to teach a language. The issue is that Java is often used to also teach object-oriented programming, and then arguably that doesn't work that well anymore. I also believe, by the way, just my personal side rant here, I think that's also the reason why some people come from university and think, oh my God, Java's so complicated, Python's so much better, for example. Because Java was used as a vehicle to teach object-oriented programming, which if you never work in a large project, often seems needlessly complex. Like I remember when I learned object-oriented programming, I came from writing like, I don't know, a couple of 100 lines long Pascal files. I was like, why do I need this? Like, this is all great. Why do I write like getters and setters? I mean, there's also like a whole anti-pattern that I learned there. But why do I write like 20 lines of code that are basically just like a wrapper or like 2 fields? I don't get it. So I think teaching object-oriented programming through Java makes it so that the students just assume that one and the other are inherently linked, and the complexity of learning one is also the complexity of the other. And if after that introduce you to, oh yeah, this is Python, I don't care, just do whatever, and they can just like write little scripts in a few lines of code, then of course that seems more productive. Anyway, side rant over. But yeah, so I think Java can be taught in an interesting and new way to new developers that lets them be productive faster. Okay, so there's much more on this. Simplified main, then the single and the multi-source file execution that you can look into here. Yeah?
I've got one question about this simplified main
Yeah.
thing. We can now like write this like few lines.
Yeah.
Is it then the compiler that just adds everything around it, like as a default?
Yeah. So 2 steps, right? So you asked about so you throw this just at Java, the launcher. Then the thing is Java C is also just a Java program. And so what the Java launcher just does is just starts basically the compiler in memory and gives it as output, just please write into memory. And when the compiler is done with it, and it's the same, basically it's the same Java C that usually runs. There's no duplication or anything. And then it just runs from this in-memory file system, so okay, now load the main class and run it from there. And yes, if Java sees, or the Java compiler sees a simplified source file that doesn't have a class, it will generate a class around it. So we'll basically take all of that and put it into a class, and then the class name is the name of the file, and then it compiles that.
Does that mean I can always omit the public class stuff?
Yeah, well, always for the class that launches your application. Never for anything else. Okay. So no top-level methods. Right, so it's only that one class where this works. And this also only works if you never have to reference that class. Like, for example, if you write a Spring Boot app, you have to say, right, like launch Spring Boot app, and then you have to, I'm not sure whether that's still the case, but you had to give it like the name of the class, .class. That's not working because you have no way to reference your own class. So yeah, like this really only works, or it's really only helpful if the program doesn't go far beyond this one class. Okay, let's talk about flexible constructor bodies a bit. So if you have a class that has multiple constructors, then I would say it's good practice that one of those constructors tries to check for all the properties and all the other ones just forward to it. You don't have to do it that way, but if you do it in any other way, there's a big risk that somebody finds a bug because some validation was a little bit off, and then you fix that validation in the constructor that you found, but you forgot that there's like 3 more constructors who do the same thing and who do the same validation, and then you have to fix it there as well. So it's a classic like single source of truth situation where ideally you have one constructor that establishes what is a valid instance, and then everything else forwards to it, where that is possible. This is what I would call constructor chaining, and it's very common, right? So here we have a class that has a first and last field, first and last name field, right? And then this is the good constructor that does all the checks and assignments, and then we have another one here, for example, you can also with a middle name, and then it does some concatenation, doesn't matter. The important part is the checks and assignments will definitely happen here as well. So in this situation, chaining is optional. You don't have to do this. In this situation, chaining is, at least in one specific sense, enforced. So now the 3-part name, which also has a middle name, is a class that extends the other class. And now, if I have this 3-part name has a constructor that takes a first, a middle, and a last name, it has to call the superconstructor. Every subclass in every constructor will call the superconstructor. Now you might think, wait, that's not true. I don't always have like super in there. That is true if the superclass has a parameterless constructor. You don't have to type it out. But the compiler will inject the call. It will still happen. The compiler will make sure the first thing that happens is you call a superconstructor. Either you do that yourself explicitly, or it does it implicitly for you. Okay, that's all great, but that comes with limitations that were very explicitly chosen. The idea here is this. the superclass should be initialized before the subclass runs any code. So the superclass, generally speaking, doesn't know about the subclass, right? So if you call a subclass constructor, one of these two entities that are like entwined needs to do their thing first. One of them needs to initialize itself first. And the argument is, let's do the superclass first, because the superclass can probably not reference the subclass in any way. So if the superclass does its job first, and then the subclass does its job, then we can ensure some consistency. Whereas if the subclass does its thing first, and then maybe calls a method, and the superclass isn't yet initialized, that's kind of weird. Okay, so the idea is the superclass should be initialized first, and that means you are not allowed to put any code before super. Because if you put like a method call there, then you could execute a method in your own class. Okay, now if you have in a subclass several constructors, and one of them calls the other one, then eventually one of them calls super, right? So, and that needs to be the first statement. But if before this constructor B calls constructor A, you could have code there, then you would still have code before eventually superclass gets called. Okay, so follow-up rule, no code before this. Because any code that runs before this is effectively running before some other super call. Okay, so you know this rule, right? No statements before super or this. So if you have a constructor of a subclass, or if you have a constructor that forwards to another constructor, you cannot type basically anything before that. Everything you have to do is you have to force it into these, into the static method call, for example, into the parameters of the super call. Okay, so the consequence of this is, if you have a class A that is extended by B, that is extended by C, and you call the constructor C, what will effectively happen is C will immediately call super, the B constructor will immediately call super, the A constructor will immediately call super to call the object constructor. The object constructor does nothing, but still runs. And so you run object ABC. This is the actual execution order of the code in the constructors. You start the call here, but because you go up the chain immediately and nothing else happens, effective code is executed from left to right, object ABC. Okay, so that's nice, until it isn't. So let's say we have this name here, there's a first and last name. And for very questionable reasons, what it does is, once it is fully constructed and assumes I'm done now, I have put myself into the right state, it takes its own instance and puts it somewhere, maybe into a map, or maybe here, or just print it to the terminal. But the point is, I take this instance and I expose it. The problem is, this is the constructor in the subclass, right? It calls this one. And this one thinks, oh, I'm done. I can take this instance and show it somewhere. But that's not true, it's not done. Like after this, we still need to initialize the subclass. And this can lead to weird results. So the idea here is that both of these classes are overriding toString. And they're overriding toString with maybe just first space last name, right? That would be a reasonable implementation of toString on a name. So that means when it calls print here, you would expect it expects to see first name, or the first space last. Now, 3-part name also overrode toString, and it of course says first space mid space last, right? Because that makes sense. But now I'm calling print line on this, I'm calling toString on this indirectly before this line ran. And so we're printing Jane Naldo, which with a print like this doesn't really matter, right? In log messages it can be mildly confusing. But if you put this, for example, for some reason, let's say you use it as a key in a cache. So you put this into a map. If this is part of your hash code, you put an element under one hash code in the map, and then you change the state, and now the hash code would be different. And you will never again find that object in that map. That is terrible. So this can range from benign to really difficult to find bugs. And the reason is, well, the whole initialize this and then initialize this plan didn't quite work out because this partially constructed instance was exposed. And this limitation can also reset elsewhere. It can make it harder, like the limitation. So we're still talking about the limitation of no statements before this and super. I showed you an actual problem it can lead to. But it can also just make some things like really inconvenient. As an example, I brought this, splitting arguments. Assume I get a full argument here, a full name here, and I want to split it on the space. And then the first character, the first part is the first name and the second part is the last name. This is the way to do it. There are ways around it. There's some workarounds, but I will get to on the next slide, or just at least mention. But mostly it comes down to you either have to repeat the work, in this case the split, which probably doesn't matter much, but in some cases it might, also just feels wrong. But you also have to repeat the code and you have to repeat the action there. There are some workarounds. You can duplicate the argument validation and field assignment across different constructors. You can do something like an internal constructor that basically takes the split, which is an array, and now you make a private constructor name that takes a string array, which you know will only come from this constructor, and that's not great. You can use factory methods, which I generally prefer, but also doesn't work in all circumstances. And record edition of limitations is the whole, you have to forward from one constructor to the other, and that is good practice. Records consider that practice so good that they force you to do it. So you cannot have two constructors in a record that both assign fields. It's just not possible. The canonical constructor, which is the one that takes all the arguments, that assigns all the fields, and every other constructor has to forward it to it. So the options are further limited. This is what we'd want to write. We're just like, okay, so name this constructor, just, everything else stays as before. Can we just please split this and then use the variable like normal people? And in the past, the rule is no statements before this are super. And what flexible constructor bindings introduce after a lot of explanation is you can now do this. So you can now have code before a call to this or super. That's called the prolog. The prolog can contain arbitrary code, except, most importantly, it can touch the instance under construction. There's like a further little caveat to that, but I'll leave that to you when you explore the feature. That's just like the general understanding. The prolog can, except to assign fields. That's important. That's an important exception. So the prolog cannot touch the instance under construction. That means it can do all kinds of things. Imagine like you were in a static method, right? That's basically the things you can do. So a lot. But you cannot call instance methods, for example. You can assign fields, though, which is important. And then you can call this or super. And you would have to do it explicitly because the compiler cannot understand what would be prolog, what would be epilogue without an explicit call. So if you do want to use this feature, you have to make this or super call explicit. And then you have like the epilogue, just a regular code in a constructor as you'd use today. So if you do this, and you have again class A, B, C, where B extends A and C extends B, and you call the C constructor, what happens now is you run the prolog of C, the first couple lines, and then prolog of B and then prolog of A while you walk up the inheritance chain. Then you execute object, and then you execute the epilogues as you would before back down. And you can use this to basically say, okay, the part of the state that is in my subclass, I'm going to make sure this gets initialized top up, and that means when the code in the super constructor runs, who is running as part of the construction of a whole like C instance of a whole larger class, but it doesn't know that, at least all the state I will already have prepared. So at least if it does actually expose the instance somewhere, the state is now correct. You can use this to check arguments, to prepare arguments. The preparation would be something like just making some checks or reassignments. You can split or share the arguments. For example, if you want to share the arguments across different variables, different parameters, you can assign fields. It just gives you a lot more freedom to do something like this, for example. Let's say somebody calls three-part name, but first is not allowed to be null, or it's also not allowed to be empty, because then why do you have a middle name if you don't have a first name? Isn't that just your first name then? So now you would just do this check early, which also means that if the check is cheap, but maybe the super call is expensive, you can now make a little bit of performance by putting all the checks very early and then putting other stuff, the actual code execution later. But that's just a side benefit. This is not meant as a feature that makes it easier to write performant code. It's only there so that you can write the code that you want without being forced by the language into a limitation that makes sense, but was maybe a little bit too strict. To prepare arguments, for example, you can do something like this. I have a short first name here that I want to produce as a substring from something else. All I'm saying is like usually what I would have done is I would have forced this into this variable. Probably I would have made a method call out of it. And that works, but it's not the code we want to write. In a normal method, I would not split this out into its own static method because it's so cool. I mean, Uncle Bob would maybe, but I wouldn't. But then you can just run the code here and put it into the super call. And the same for the argument split. Just create a variable and reference it later as you want to. Now, surprising cameo in this feature is Project Valhalla. Project Valhalla is, I'm going to mention a few things now. If null restricted fields, something that doesn't mean anything to you, that's okay. I will not have the time to go to detail here. You can ask me a question over snacks later. But if you heard about Valhalla, and if you heard that it wants to introduce so-called null-restricted fields, then that is actually interesting, because the way Java works is your constructor is not actually constructing the object. The language or the runtime is constructing your object, and then it tells your constructor, could you please do your thing with this instance? So the instance is created with all its null, all its zeros. Please run the constructor. But then if we want to have non-nullable fields, then creating an instance with all null fields seems kind of broken. Specifically to talk about subclass and superclass relationships. And so this is where this comes in, and that's an accident actually. So this feature was started to be developed regardless of Valhalla. But then Valhalla looked over and was like, hey, that would actually solve our problem. Because this way you can make sure that all null restricted fields must be assigned before the path of execution leaves the constructor, for example. Okay, so if you want to learn more about that, last year's JVLMS talk by Brian Getz, Valhalla, Where Are We?, goes into a lot of details about Valhalla in general, but then also this specifically, so there would be details there. Otherwise, JEP 5.13 and the video we made about that on flexible constructor bodies. Okay, ahead of time computation. 2 more topics, then we take our break. Java has extremely good performance, but only if you talk about peak performance. If you talk about startup and warm-up time, it's not quite that amazing. And that is because Java does a lot of things. We think of Java as a static language, but that's only really true for the type system. Not everything else, but a lot of the other things that Java does are very dynamic and can only really happen at launch time. So for example, class loading is something that only depends clearly on what is actually on the class path, which is only known at launch time. That basically calls that linkage, which is making sure that the method call here actually links to the right method call over there. Constant pools need to be resolved. Then all of that runs in the interpreter, which is gathering profiles, and then eventually the just-in-time compiler kicks in. And all of that happens on every launch. But the thing is, if your application launches a lot, and every time it launches it does the same thing, then all of that resolves to either exactly the same or maybe probably very similar results, right? And still you're redoing it every time. Could we do this ahead of time? Or in other words, couldn't we just do everything ahead of time? Like everything that Java runtime does, we could just do it ahead of time while we build the thing, then it could just start with peak performance. Wouldn't that be great? But I just mentioned that Java is very dynamic. And most of these things do depend on a state that is not yet known. So for example, access control. Not only does it control what public and private and package visibility to use, it also depends on, for example, command line flags like add exports for a module. That can only be known when the application is launched. Runtime typing and casting only really works at runtime. There's so many things here that Java needs to kind of like dynamically gather insights at runtime that cannot be statically predicted at build time. It's just not possible to know all of this. So if we still want to do everything ahead of time, we basically need to have a way to just look into the future and just be like, okay, so this is what the future will be like. We don't have that, unfortunately, although I'm guessing Brian Getz is working on it. What we're using instead is we're going to use training runs. So the idea is, okay, we do not know the future, but we can do things that simulate the future. And then we can take insights from that, and then we can use those insights to launch. So that's the whole idea behind the head of time cache that Java is introducing right now. So Project Leiden is working on that specifically. The idea is to observe the JVM in one of those training runs, then capture the decisions that will make then an AOT cache. And if you've ever worked with class data sharing, you might recognize the process. It's basically an expansion of that. And then you use that cache as the initial state during a future run. But importantly, when any of those observations turn out to be false in practice, then just fall back onto the regular Java behavior where you find this out at runtime. So with everything, I'm going to go into the second what is already being done or planned right now. Everything that is being done right now, the worst you can get is the performance is actually worse than without the AOT cache, because it started to use the AOT cache, then noticed, oh shit, this thing is actually invalid for reasons. I need to go back, I need to do the work by hand. So you would end up with worse performance than if you just not had the AOT cache in the failure case, where these assumptions turned out to be wrong. But you will never get incorrect results. You will not be in a situation where Java is like, oops, the training run did this, and then in runtime happened this, but okay, so that's why I made mistakes here, right? So let's say in a training run, an if only ever says true, right? Then the just-in-time compiler will eventually very aggressively say, okay, we're just going to assume that only the true exists. I mean, even then, it builds a trap, and if it's ever false, it falls back into interpreter mode. So even that is not a good example. I think I cannot come up with an example where it could even theoretically break, I guess, although it do surely exist. The argument I'm making is, with the AOT cache, it will probably launch faster, and we're going to see more details on that. But if it doesn't, because those assumptions were wrong, the worst thing that can happen is a slight hit in performance. So the AOT workflow in general is 3 steps. Creating a profile from a training run, you don't have to look at the details. It starts the application and says, record, please, a profile. Then you do an assembly phase. You do not launch the application. You just give it the information of, here's the profile you gathered. Here's all the stuff on the class path. Do a thing. And the output of that is a cache. And then you use the cache for the actual production run. You reference the cache. And Java has simplified that process a little bit. This 3-step process is still needed in detailed cases. But for most cases, you will probably get away with a 2-step process, which is run the application once in this training run and create the cache as output, and then use that input for production. And although in a Dockerized environment, it's not clear how much value that really gets you, although you could probably link in an external device. In the future, maybe you just use one run and just like launch the application. And it's an actual production run. But then while you're working on it, please produce a cache. And then later instances that out later can then launch faster with that cache now that it exists. But that is not there yet. But there's this project line is still very early in all of this. And so specifically like these usability improvements will probably come, and there are a lot of plans for that, but it will still take time. Okay, so what does the AOT cache actually do? The thing it does, one of 2 things it does at the moment is class loading and linking ahead of time. The idea is to improve startup time by making the classes of an application instantly available in a loaded and linked state when the hotspot JVM starts. What it usually does is it just looks at this file system, just loads all the bytes, then needs to verify that those bytes in there do not violate the Java virtual machine specification, meaning that it can just randomly crash the VM, and then it puts into some internal data structure. And that process is deterministic and will always yield the same results on every launch as long as the classes are the same. And so this is class loading and linking. And that is can be done ahead of time, which for the Spring Pet Clinic led to a 30% startup time reduction. So that's like maybe something between 20 and 50% is something that you could reasonably expect. And just to give you like a ballpark figure for Spring Pet Clinic was about 130 megabytes.
That sounds like a lot.
That you see like Java the JVM is doing a lot. That's just a lot of classes, right? The Pet Clinic uses a big chunk of what Spring has to offer, and so there are a lot of classes involved, and yeah. So that means like real life applications that do a lot of things. This number can get much larger, yeah. This one should basically scale with the number of classes. So depending on basically size of dependencies that you're using, and then your own code.
What's the difference to crack? Check by
Yes, that's a good question. So crack works on a different level. So crack basically works on the level that you can freeze entire applications. So that means that, first and foremost, even though there are hooks, the application doesn't really know that it's being frozen, right? Like it runs, and then the operating system just says, and then just freezes it. And the application, there are hooks that it can use, but then it will later reinstate the entire thing. And that means your application, for example, would not go through startup, like everything that Spring does on startup, like reading configuration files or whatever else. That would not happen with crack, right? With crack, you just get the old state bit, which might very well what you expected, what you want, right? Because you only want, the configuration probably doesn't change that much. Again, like in a cloud environment, you probably have that set in a way that you would do a new release, basically, or new push to production anyway. The problem with crack, from my perspective, is that the code needs to be very aware that this happens. So every open connection that you have will just be, from the point of view of the application, will just be suddenly gone, whatever connection it had open. I think that one is actually quite forgivable, given that a network is unreliable, and most code you write should be okay with network not working anyway, right? But that could also be true for the file system. It's reading a file now, and in the middle of reading the file, it's just, oops, the file is gone now. That also means that if you, let's say, you want to do something in the application every minute, so you take the timestamp of now, and you check occasionally, are we 1 minute later? Suddenly, your application relaunches, and now it's 35 days later. And you're like, what? Do you do the same thing now 35 by 24 by 60 times? So that, it's not sure how your application will react to that. Crack has a fix for that, which is a hook that you have to register, that you hook into. And you're saying, okay, so do this on shutdown, do this on restart. And with that, you can fix all of these situations. The reason why I think that, or although Brian gets said that because it was asked that at DevOps Belgium, why Crack is not really moving forward a whole lot in OpenJDKs, that means you get a feature in OpenJDK that basically allows you to very subtly break your application. And then how do you get back to correctness? Good luck. And that's not usually how Java works, right? I just described that the IoT cache starts on the other end. It will guarantee correct results. It will basically guarantee no worse performance, and it tries to work from there. Whereas Crack basically starts on the other end and is like, look, this is really fast, but if things don't work, you get no real help. Like, you have to figure it out on your own. And the way it breaks is not always with like very obvious exceptions, but with subtle misbehavior. And I don't think that that's a feature that I think this feature is too much of a foot gun to make it available to every Java developer. If you need it, you know where to get it. You know, like this makes AWS Snap Start works very similar as well. Then this feature is available. But I think the way it works right now, I don't think it's really just an every man's feature, so to speak.
Okay. Will IoT class loading and linking work with the change class path?
Yeah, it will notice that the class path is different and will just kick out the cache. So that's a classic situation where you basically get the same performance as without the cache, minus whatever you paid for pushing 100 megabytes over the wire or whatever.
So it won't notice that the performance improvement in one part of the code that were previously there and still in the code, and then reuse it with a changed code base. So like, for example, that I made a test run, a performance run, which optimized whatever regarding one specific database connection.
Yeah.
I didn't change this part of the code, but I changed some, I don't know, business logic around it.
Yeah.
But I would still like to profit from the computed IoT cache.
Wait, the question is like class loading and linking depends on the class and what classes are there and right. So if you run with the same class path, you're good. But if the class path looks different, and looks different can just be a reorder of something, right? Because if two jars contain the same class file, then it will only be loaded from one of the jars, the one that is first on the class path. So if you then launch the application, the class path items are turned around, things could be different.
Okay.
And this is no good way to figure out whether they are. So instead of like trying to figure it out, it just says, okay, so the information that I start with now are so different from what I was training on that there could be misbehavior.
Okay.
So let's not do this. Okay. So then the cache gets kicked out. Ideally, the IoT cache, if you want to use the IoT cache, you should create it on every push to production. The other thing that Java does now is method profiling. So not just-in-time compiling, just the profiling, right? At first, every code runs in the interpreter, and the just-in-time compiler is trying to figure out where to go to optimize stuff. So it's just observing through these profiles what is happening. And with IoT method profiling, those profiles can be gathered during the training run, and then they will be embedded. And then in production, basically, when the application starts up, the just-in-time compiler can immediately see what methods make sense to optimize. So the training run should expose your application to a realistic workload during production. And if during production you take like, let's say 10 seconds to reach peak performance, then I would say that in the long run, because IoT doesn't do all those things yet, right? You should probably exercise your application for a similar amount of time. So the ideal case is you do something like a canary deployment. You just take your new version, put it into production, the first launch is slow, and you accept that. You build the profile from there. Then you use that profile for every other run, because that's production data, that's probably the best. But maybe that even doesn't work, because who knows, maybe production data is like shifting a lot. Maybe in the morning you only have these users, in the evening only you have those users. The next best thing is a dedicated performance benchmarking training run, where you set up something where you say, okay, I know what overall the profile on my application looks like. I'm going to generate that data synthetically, and I'm just going to hammer the applications. I'm going to launch an instance, hammer it for a while, and then create the profile that way. You might also just benefit from running regular tests. Although, we're getting further away from what will actually happen in production, but like the profiles, for example, might not be that spot on. But the class path, right, like class long linking, that would be. Although the problem there is, if you just do a regular training run, regular test run as a training run, then the regular test run has all those test dependencies on the class path, which would differ from the actual class path. So that it doesn't quite work like that. You would have to have either a separate class or a separate instance that you're launching.
And
yeah.
let's assume I have my production load, my reference
yeah.
load characteristic, and then it takes a few seconds, or?
Well, the training run takes it. So the idea about the training run is you wanna show the JVM what it has to do in production. So if you want to just improve the launch time, then just launch your application and shut it back down, because then we'll at least like do all the class loading and linking. You say like, no, I do care about the method profiling, and maybe in the future there could even be the optimized methods could be in there. Then you have to get the JVM to that point. So if your application in real life takes a minute to reach peak performance, then maybe the training run should last a minute if you want to get most of it. Although I haven't used this in practice, but I'm really sure that this is like a diminishing returns situation, where I'm pretty sure you can get a lot with just 10 seconds. And you don't, like the other 50 seconds will probably contribute much, much less to the overall speed up that you would see. But yeah, that also depends, or that's also something I think that we'll see over time as the community starts to put this into practice and report their findings. So if you do use this, that would be great, right? I said, okay, so this is what we observed with different lengths of training runs. I think that's really interesting because this is a thing that Java didn't do before. And so I think there's sort of like good practices to find and, like just intuition to build to understand how this works. This specifically gave some reduction on a very tight loop of something, so it might not be that extremely representative, but it can get you runtime reductions as well. Okay, so there are some limitations. The JDK that runs in production and the JDK that you use for the training run must be the same release, the same version, must be on the same CPU architecture on the same operating system. The class path between training and production must be consistent. I will refer you to the JEP, what exactly that means. Like I said, the order, but one of them you can prefix the class path. Go look that up if you're interested. The module options have to be consistent. So if you do add exports or something like that, that has to be happening in both places. And JVMTI agents use are limited because agents can, on loading, manipulate bytecode. And so that's a thing that can basically like void all assumptions. So that's a thing that then that you shouldn't be using. Okay, if those happens though, the runtime will realize and be like, okay, well the IoT cache is useless now. You get a message that's not being ignored, and it will move on from there. All of this came in 3 different JEPs. So this was the first one, IoT class loading and linking, and then method profiling is the second feature. And I told you that we got 3 steps initially, and now it's only 2 steps. That was this JEP. Last October, Billy made a video about all of that. And they are working on more. I think there's already another JEP in the list of JEP drafts where Leiden does more, which might, at the speed they're currently pushing things through, land in 26. Okay, can I keep going for the next feature even though we are over time for the 45 minutes? Yeah? Okay, then just to finish the 25 stuff. Okay, so we're talking about compact object headers here. This is a performance improvement that happens in the runtime. The runtime needs to track information for each object, for each instance that you have. The garbage collector needs to put some information there. The type system is very interested in learning. Also, you have data here at this memory location. What type is this actually? Is it instead of a string or an integer? Clearly makes a difference. So the type system wants to see stuff. The whole synchronized mechanism, the whole log mechanism, a monitoring mechanism needs to understand information about a specific instance. And then the identity hash code, once computed, is also stored. And so all of this information is relevant and important per instance, and it's stored in the object header. So your object, you probably heard of that before, right? So the object of an integer is what's like a 32-bit int that's there, plus however much this is. On 64-bit hardware, it will be 96 bits without the feature I'm presenting to you, which you might notice as 3 times as much as the int was. You have a bunch of H headers for the garbage collector here. You have the class word, or the compressed class word, which points at what class this is. You have the identity hash code in here. There's some tag bits, and the dots are empty. The details don't matter. I'm just showing you we're blocking 3 32-bit blocks with the object header. Currently on 60-bit hardware, that's the default configuration. In production, real-life objects tend to be small. So on most workloads, the average is somewhere between 256 and 512 bits. So that means on those workloads, 20 to 30% come on top of that. That is just headers, which is, is a decent chunk of memory that is there. And so the idea was by project Lilliput that this is definitely worth optimizing. The problem with that is all the subsystems I just mentioned are both very essential for correctness, and they are not trivial, and they're also very performance sensitive, right? Like every type check you need to do, those type checks need to happen a lot. So adding, for example, a layer of indirection can impact performance a lot. So, and this was also just like the easy part. Like there's a hard mode here where locking operations override like 62 of those bits, and then all the other bits get moved around, and it's complicated. Project Lilliput proposed this though. They worked on this hard. They had this idea, Roman Kenke developed that while he was working at Red Hat, and he moved to Amazon, and then a lot of people within OpenJDK worked the last couple months to get this to the point where now this feature is no longer, wait, I think is it? It might still be an opt-into feature. I will see that later. But the point is now we got rid of one of those 3 segments, so now it's 64 bits with this separation of them. Let's not go into there, but a few bits are kept for Valhalla who might need this. The thing is that these changes might have some downstream effects. So locking operations used to override some of those bits. They don't longer do that. The class word is smaller and it's also encoded differently, and there's an O missing here. The GC forwarding operations, GC has to figure out when it moves stuff around, like what stuff is already moved and what isn't yet, and that all gets more complicated. And that means like this compression, while it saves memory, can under certain circumstances lead to performance degradations. And that's why this is not a neutral feature, it's just not plain better. It can lead to problems. The interesting thing though is, it not only leads to less heap space in many benchmarks, it also routinely leads to less CPU time, which is not obvious at first because we're just saving memory, right? But yeah, the memory is used more densely, so you have less cache misses, for example, and that can improve runtime. And that means that some of those downsides I just told you might just get either zeroed out by this, or there might still be some benefits left over, so they get less CPU time here, for example. Or JSON parser benchmark runs in 10% less time. So there's definitely, we're assuming that there's going to be less memory consumption, and then there's hope that most projects will see even faster computation, or at least no worse computation. And right, you still have to try it out. So if this is interesting to you, if you're like maybe in the cloud, you have like a whatever gigabyte memory limit, and you're very close to that, and maybe think, oh, 10% more memory, that will really help me. Give this a try. --XX : plus use compact object headers. And if you do use this, whatever you observe, even if it's just all good, please go to the hotspot dev mailing list and report that. Specifically, if you have a problem, you have a very high inclination to report it anyway, but it's also important that those people who do not have a problem, occasionally at least, come back to the mailing list, so that it can be observed, at least roughly, like how widely spread these problems are. Because this might in the future become either the default or maybe even the only header encoding. And then also Leiden has a stretch goal of Lilliput has a stretch goal to try to get to 32-bit object headers. I'm not aware of what the progress on that is though. If you have compressed class pointers off, contrary to the default, or if you have stack locking on, contrary to the default, then this will not work. So the default setting in these two situations must be kept. Again, you will get a command line, you will get a terminal will tell you that you're doing something wrong if you try to combine these. But if you do any of these in the non-default settings, be aware that this won't work. Okay, so I usually only link the JEP which finalized the feature, but this JEP is not very informative. This one is much, much better, which is the draft where it was introduced as an experimental feature in 24. So read this for details. And then again, I made a video about that where I tried to rebuild object headers with Lego, which was fun. Okay, good. That was all 25 stuff. I also have deprecations for you, but I keep that as a surprise until we come back. And then after that, we can pick any of these topics to discuss next. Yeah?
I was always wondering how this instance of thing works.
Yeah.
Does it just read the object header?
That's my assumption, yeah. I don't know that, but yeah, I would assume.
It sounds reasonable.
Yeah, exactly. Sounds reasonable. Yeah, that's exactly why I said yes. But again, like it's a difference between thinking something's reasonable by having looked it up. So just want to make clear I haven't looked it up. But yeah, that's my assumption. Yeah.
You said that there were like 32 bits for this compressed class name. I've always wondered, like, what if this class name is like very long?
No, the class word is not the class name. The class word points into another data structure that contains that. And that also means, by the way, if you have fewer bits for the class word, you have fewer classes you can actually have. So the limit used to be higher, which was like, I think, 4 billion classes, I think, which seems excessive. Or was it 4 million? Maybe it was 4 million. Still, a lot of classes. But that number is closer now. So the question is, do there exist because clearly this is not classes that people wrote by hand. But some libraries might, or some agents might spin up bytecode. Maybe for every X you do, they build a new Y. And maybe for every Z you do, they build a new Y prime. And if you use both, they build like, who knows, right? So the question is maybe we run out of bits for the class word. So far, nobody has said yes, but that's why it's important that people try this out.
So it's like an ID and there's like some kind of hash map with
Yeah,
kind of
basically.
millions of classes.
Yeah. If you're interested in that, because I knew, like, I'm kind of knowledgeable about what happens above the waterline, like in the language and the APIs. Everything that happens within the JVM is still a lot of a mystery to me, because like the abstraction really works well. Like you don't need to know all that stuff. You can still be a decent Java developer without really knowing like how ZGC tags, like whatever. But if you're interested in this, the JEP is really well written. I recommend giving the JEP a read. Like it really explains these subsystems, at least to the point where I felt like, okay, in the context of what I need to understand the JEP, they really explained them well, and so that was interesting. Not necessarily an easy read, but it's an informative read, and if you're interested in this, I would give it a try. Okay, let's talk about deprecations, because things are also going out the window occasionally. So if you, no if here. These things are already gone. No matter what Java version you're on, you might already have those things in the runtime that you're using, but they are gone. So definitely stop using those if you are. You're still running 32-bit hardware? No? Good, okay. Security Manager is the most likely thing that you might still be using. So let's talk a little bit about that. You probably know the Security Manager is a system of checks and permissions that was intended or is working to safeguard security-relevant code sections that you would often use in where you load code that you don't trust, right? Like in a container environment. And its embodiment is the class called Security Manager. And I'm not going to go into all the details of Security Manager. I'm actually going to go into basically none of those. I just want to tell you what the current state is. So the Security Manager is not used very widely. Does anybody use it here active in their project? Okay, that's what I thought. I have way larger audience, but also nobody raises their hand. So that's very common. The problem though is at the same time, every feature that is being developed touches on security somehow, so it needs to be included there. So it's a constant maintenance work within the JDK, within OpenJDK. And so that was why the decision was made to phase it out, because on the one hand, it provides very few people with benefits, but then also everybody pays by just having slower development time. On top of that comes that arguably it's not that easy to lock something down with the Security Manager in a reliable way, so even those people using it might not get all the value out of it that they're actually hoping for, but that's a different discussion, so I don't want to get into that here. Since JDK 18, the Security Manager is disabled by default, and in 24 it is removed. That means if you use a command line flag to activate the Security Manager, you will now get an error. But the class still exists, it's empty basically, and all the calls are no-ops. That is important because your dependencies, for example, thinking that you might run a Security Manager might check for that, because some of them do. And the usual way to do this is they ask the system for the Security Manager and then check whether the return value is not null, and if it's not null, they do things. That's the common pattern here. But now, for example, system get Security Manager, I think is the method called, will return null, for example. If you get an instance of Security Manager anyhow, and there's certain checks that you can do on that, and you call those checks will always be like, no false, I'm deactivated, whatever. So that none of the code that relies on the Security Manager tries to jump into action and do something. But you should look into your own code and potentially also into dependencies to get rid of that. So you can, if you're on an older version of Java, you can run the Security Manager disallow to basically simulate the 25, the present in which 25 exists. And yeah, as it's used, you should move away from that. Then there are a few things that are currently being deprecated for removal. That is memory access via unsafe. finalization, that's one that we're going to look at in a second, and then the applet API. And this ticket says remove applets, and so it's not yet a JEP, so that makes sense to keep an eye on. There are two things which will definitely stay allowed. These are not about to be removed, but they are disallowed by default, and that is JNI and dynamic agents. The idea here is that JNI, the Java native interface, which can call native code, and that native code can corrupt your JVM and crash it. And then dynamic agents can randomly change the behavior of your application. And the issue with those two things is there are a few technologies like this in the runtime that allow you to do stuff that will void or allow other, not yourself, but also other dependencies to do stuff that basically voids a lot of Java's guarantees. Right? You thought that field was private and it was important to you, but you had an agent that on running made that field public through bytecode manipulation. Probably the agent doesn't do that. What I'm saying is certain guarantees that Java gives you, those things can void those. And the idea is you should only turn this on if you know what you're doing. Like you say like, yes, I'm using that agent and that's intentional, and so I'm going to allow it to do those things, but they should not be allowed by default. That's all what this is about. So have you ever heard about integrity by default? That's what this is. What this is about, making sure that the Java platform has integrity, and those features that basically can void that integrity, that you have to opt in and not have them on by default. Okay, I said the memory access and unsafe is going away. In fact, all of unsafe is hopefully at some point going to go away. So the class sunmisk unsafe had a bunch of different things. Memory access methods were superseded by var handles and then by the foreign function memory API and will be phased out. You are here, if you're on 25, you get runtime warnings. In the future, we get exceptions on invocation, and they will eventually be removed. The problem with unsafe is that it was never meant as a public API. That means it's not written in a way that is reliable to use. It's a big foot gun, and it's not supposed to be in the umbrella of we have to maintain this in a backwards compatible way, and for those reasons, it's removed. Okay, so you are probably not using it directly. If you do, you know, or some developer who's not with the company anymore did something nasty. But usually you don't, but your dependencies might. You can run with sunmisk unsafe memory access set to deny, which is my recommendation. Run something that is not carrying the billion-dollar contract through your company right now. Maybe run this as tests or integration tests, or maybe have one instance that does this in production, and hopefully that way find out all the unsafe memory access that you have and then report them and maybe help fix them, right? If your dependency uses unsafe for something, they might not have the time to work on refactoring that to a foreign function memory API. Remember that open source is, well, you guys, you probably know about open source, but it's not just, taking, also giving back. This is a great way to give back to the community. If you find with any of these changes, problems in your dependencies, and the developers are not in a position to really spend a lot of time on that project now, try to support them in some way. It could be monetary, it could be with work. Let's talk a little bit about finalization, unrelated to unsafe. Finalization is a different thing. You probably have seen finalize methods on object. Those are very kind of weird. You're basically saying, yeah, this class has a finalize methods, and that means that after the instances are no longer used, I want to do stuff. And so every class that has a finalize method, all of those instances get registered somewhere automatically, and then the garbage collector, when it finds those, it will later have to run them. And the problem is that is very unreliable. You do not know when this is going to happen. This happens on cleanup by the garbage collector, which might be an arbitrary point in the future, which is terrible if finalize, for example, is used to close, let's say, open file handles. You open file handles, and then in finalize methods, you close them all, but GC might defer collecting those objects so late that you might just run out of file handles, even though you have tons of instances that you could clean up and they would release those file handles, but it just doesn't happen. Which is why Java implemented the try with resources, or try with resources block, which is the primary placement for this. Okay, so finalization is going to go away. You can already, again, simulate that future with finalization set to disabled, which will at some point be default, and then a lot later, I don't know when exactly, but I doubt that this will happen before Java versions turn 30. In a later release, finalization will be removed. So the way to solve this is you look for finalize methods in your code and replace with try with resources where that is possible. That should always be the first try. If that doesn't work, you can use the cleaner API. The cleaner API has some similar properties to finalization. It has some of the downsides of finalization it worked around. Some other downsides are inherent to this approach, so it also has that. So that means, like, that's why try with resources should be defaulted. That is possible, that's definitely the better search, or the better way. Then look into the dependencies, and again, help them work on it. And the way to try this out is to run with finalization and disabled, and then closely monitor the overall behavior of the application, but finalization is most often used to clean up some kind of resources. So do observe those resources, maybe network sockets, as I said, file handles, whatever else you might have. That is what is most often being deleted in finalization. Removed in finalization. Jay and I already talked a little bit about this. Native code can undermine your integrity, and you should do this knowingly. So you have to say enable native access to allow JNI and FFM. And then for the time being, you can also say, okay, and if for those libraries where I didn't explicitly allow them, all the other ones that are still doing this illegally and under covers, how do I want to handle that? And again, we've seen this a bunch of times now, the same escalation. On JDK 24, if a library does JNI without you having allowed it to, you will get a warning. You can already set this to deny, which again is my recommendation to do now. And that way you make sure that nobody is doing JNI under the covers, and whoever does, you have to say explicitly allowed. Last one, I think, agents. Agents are components that transform bytecode with specific APIs, and you can either launch them with the JVM, or you can attach them later. And the whole launching with the JVM, that part, since you do have to do it explicitly on a command line already, that part is not covered by this, right? So you're already doing this explicitly, so you're good. But dynamic agents, meaning ones that attach at runtime, those you will not be able to do by default. So all mechanisms for that remain intact, and that will not change. But in the future, the attaching of an agent will be disabled by default. And again, and you can enable it with this flag. Just as a preparation. You cannot do this now. You can already set enable dynamic agent loading to minus, so to turn off. And then dynamic agents will not be able to attach, and then you would see, if you would use them, see some misbehavior. Dynamic agents are interesting in the sense that the way they are designed, you should really know when you're using one. But the thing is, since they're very useful, some libraries might use them to do the thing that they actually want to do, without telling you necessarily, which can lead to the downside that now we have an agent running that has a lot of leeway to do a lot of things. We just talked about security in depth, which means that this library doesn't even have to do something nefarious. It could, for example, have its own independent security vulnerability that then can be used through the agent to expose more problems in your application. So dynamic agents are a good feature, and the feature will stay around. You just have to enable it explicitly in the future. I mentioned a bunch of JEPs there, I think. Hopefully, did I mention a bunch of JEPs? I don't recall mentioning JEPs. I think I removed that. Okay, great, cool. So that means all the aforementioned JEPs are not mentioned anymore. There are a bunch of JEPs on all of these. Let's do something. Let's go to, oh wait, that's the wrong tab. Let's go to the JEP list. So that is openjdk.org/JEP/0. I'm offline, never mind. This would be a full list of all JEPs. So if you ever want to see all the JEPs, including all the draft JEPs, all the states they're in, just go to the JEP 0, just go to any random JEP and replace the number with a 0. And then you'll find that full list. And if you search for any of the things I just mentioned, you will find, like dynamic for dynamic agent, you'll find it. That's a good way to see what's currently happening. Okay, good. Otherwise, there's a JEP draft on the whole integrity by default topic, which I just mentioned, which explains why this is important, which features Java has that can undermine integrity, and what is done to make sure that they are only turned on by if you really need them, or otherwise replaced by safer variants. And videos on that. Yes?
Do you have an example of a dynamic agent? I'm just thinking if I've ever used one.
Yes, so that is something that you can use to, for example, get telemetry data out of a running application. So you have an application running, and when you start getting telemetry data out of it, you can you can attach a dynamic agent, which will then change the bytecode of everything and inject that. I think also that Mockito does that under certain circumstances, because bytecode manipulation that way is just more powerful than what you can do with annotation processing, for example. which might also mean maybe, I'm not thinking Lombok has an agent. I'm not sure. So yeah. Most people use, like, if you use an agent intentionally, you're very likely aware of it. One critique that I heard about this thing is that if you are in a situation where you need to attach an agent at runtime, because that's like, you have like a very weird bug, and you like only once you observed it, you have a chance of maybe finding it, and then an agent might help you with that. That's usually not the environments where people have this flag turned on. So the critique is that you cannot easily later attach an agent in a situation where you'd want to. Okay, now it's your choice. This is the menu. I think we have about 25 minutes left, right? Is that about right? No. Yes, no? More? I'm not sure. You tell me.
Maybe a little less, I guess. I don't know. Yeah, usually we finish 8:15.
Okay, so then
We can also do it longer.
We can do it till past.
after every topic, people are allowed to leave, and then we just keep going.
But you don't have to leave. You can also go in the kitchen and chat.
Yeah. Okay. Yeah. Do you want to pick anything? Anything you're interested in to talk about? That's all the things that happen between 22 and 24. Class file API. Let's talk about class file API. Okay. So we already talked a little bit about bytecode manipulation. So what is bytecode really? This explanation is actually I realized when I walked. Raphael Winterhalter talked about this, who was like an expert on all things bytecode. He made me aware this definition is not entirely quite right. So bytecode is that. Yes, bytecode is the instruction set for the JVM. It's basically what your Java code in the method bodies is expanded to. It talks about creating objects and arrays and copying variables and invoking methods and all that stuff. That is true, or that is correct. But there's more around that, which I didn't quite have on my radar when I wrote this, which is, well, your classes don't only have method bodies, right? So for example, you have method signatures, which is like the name of the method, the exceptions, annotations. You have constant pool. You have those things, which are not literally instructions for what to do, but are just information that the VM needs to operate. That's also all in the class file. So that's also all part of that. Okay, so that's what bytecode does, and then the bytes in the class file generally contain this other information. And I think most of what I say from now on is correct, not only for the bytecode, but for the larger class file too. So, you know, when you have a .class file, the bytes in there, right? So if you explode those bytes, you look them in a hex editor, they will contain all the meta information, and then they will contain the method bodies, which are this. So JavaC generates that stuff, stores it in a .class file, and as I mentioned before, it's loaded, parsed, verified by the class loader, and then the JVM executes it, which sounds pretty straightforward. But in real life, it's not. So frameworks might generate bytecode at build time. The just-in-time compiler or GRAL native image might turn into machine code while it's running. The AOT cache that we just discussed might prefetch it. JDEPs, Spotbugs, and other libraries and tools might analyze it, and agents and libraries might manipulate it. So that's a lot of stuff going on. So I have made this somewhat weird diagram. This is supposed to be the class files. This is supposed to be their representation at runtime, the bytecode at runtime. And so initially you would think, oh yeah, the class loader loads this and turns it into this, and then the JVM executes it, and it's all good. But then comes everything down here, which also all works with that. And the way that a bunch of these tools, specifically those outside the JDK, but even some within the JDK, if I'm correct, do this is through third-party libraries. So they don't necessarily manipulate the bytecode themselves. So for example, Hibernate and Mockito do that. They don't do this directly. They use other tools to that. A bit plan that is ASM or ASM. I think it's generally referred to as ASM. If you heard about ByteBuddy, for example, it uses ASM. But also it might use ASM directly. Okay, that's all good, except it leads to some migration pains. So this might become familiar as I'm talking through it. So the bytecode has a level. That means, for example, Java 21, the bytecode level is 65. And so every Java class file starts with the cafe bytes, right? And then soon after it mentions which bytecode version it is, or bytecode level it is. And a tool like ASM cannot really reliably work with bytecode that is newer than ASM itself, right? If ASM only knows about Java 21, then it cannot work with bytecode that is generated by Java 22 because there might be all kinds of constructs in there that it doesn't know. So what these tools do is they check for the bytecode level, and if it's newer than what they're aware of, they're just saying, I don't know what to do here, and then they stop doing stuff. And this can block updates. So let's say you're running now, let's say you have a Java 21 app, everything's working fine, and you change the runtime to Java 25. If you just change the runtime, that's all good, right? You might get some minor performance improvements, you can pick the new GC, you can pick ORT caching, that's all good. But at some point you want to use the language features maybe, so you start compiling to Java 25. And suddenly, this number switches from 65 to 69, and ASM says, in the old version, oh, I can't use that, so you have to update ASM. But ASM is often shaded, or it's a transitive dependency or some other tool. And then you might have to start updating, you just want to update Java, but now you also have to update ASM, and that might just pull in all your rest of the dependencies, and suddenly you're in a situation where people like I tell you, well, to update the JDK, the best first step is to update all your dependencies. This is one reason why that is true. It's not the only one, but this is the main reason why that is true. Just because as soon as you spit out new bytecode manipulation, which is very common in the Java ecosystem as a whole, even though nobody does or very few people do it themselves, a lot of the tools we use it, which is not bad, by the way, there's nothing wrong with that. It just leads to this unfortunate situation where you might have to update everything just because you want to update Java 25. Right, so this is the reason why that's something that I frequently say, and it would be nice to move past that. Okay, in comes the class file API, which is an API within Java that allows analyzing and manipulating bytecode. So it's a stable API within the JDK. It's necessarily always up to date. So that means when you update your JDK, it comes with the updated class file API. And it may come across new bytecodes, right? That still means like your use case might be, for example, let's say you use a tool that analyzes dependencies. So it basically goes through all the import statements, right? And it says, give me all the import statements. Now, if there's a new bytecode that is unrelated to imports, you don't care. So many use cases will still work, even if the library you wrote didn't know about all of the constructs. So ideally, you end up in a situation where this is much, much more common. You update Java from 21 to 25. Since Spring Boot now uses the class file API directly, or probably some other project in there, but just for simplicity's sake, uses the class file API. As you update to 25, the class file API is also updated. It can, of course, read the Java 25 bytecode, so this part is all good. As long as none of your features depend or need to be updated for any of the new constructs, you're good to go. And that's it already. So I do not have code examples for you, because I'm assuming that, like me, you probably don't write bytecode manipulation very often. All that said, I did write a little bit for a specific use case for the Java playground, which I mentioned earlier. But yeah, so the JEP shows a little bit about the code, but it also doesn't go into terrible detail. You can check out the JavaDoc for that, but the API is written in a way that this is very stream heavy, and the idea is that you define what you're interested in and then basically process a stream of those things. And so that ideally, all things you do not care about, you can just ignore. Brian Getz gave a great talk, class file API for the JDK, where he motivates all of this and goes a little bit into the design, also without showing a lot of code. And then I made this video, but I just told you, I think, basically everything that's in the video. If you're interested in seeing some code examples, I might have some for you after the break. Although it's not like the API itself is not exactly like very spectacular. It's also something that it wants to do is, and like ASM, it also wants to achieve some API improvements for the people using that API. And so ASM is very visitor heavy, and class file API uses data-oriented programming a lot and also tries to have reading and manipulating bytecode to look somewhat similar as opposed to ASM, which makes them look very different. Okay. Anything else? Or questions, I should probably say. Let's talk about stream gatherers. So I like using streams a lot. A lot of people, especially some former colleagues, will tell you I like using them too much. But there are some intermediate operations that are arguably missing. Like sliding window, for example, where you, instead of processing one element, you always want to process that element and the one before and the one after, right? So one of that would be a sliding window. Or fixed groups, which is the list of users gets, or the list of museum visitors gets mapped into a list, or the stream, I should say, the stream of museum visitors gets mapped into a stream of groups of visitors, right? Where all 5 people go into one group. Nope, that's not really easily achievable. Some of those things you can rebuild in a buggy way, and I've done that. That's fun, but it's not fun to use them. Take while, for example, is really great. I like drop while and take while. What I hate is when you say take from a stream while this predicate is true, but when it turns false, that's actually the interesting thing I'm interested about. I want to have all the other elements plus the one that broke the predicate. Also, again, there is a hack you can do this with. It's not nice, so that's something you can do. So clearly what I'm saying is like, it doesn't have all possible operations, which is probably not surprising. It had a similar situation with terminal operations. Also, streams don't have all possible terminal operations. But that was never really a problem because A, the ones that it had are probably getting most people very, very far. But more importantly, it had the concept of a collector, which is the generalization of a terminal operation. Whatever could happen at the end of the stream, the collector's interface or concept captures that. First of all, there's a specific interface which is called collector. There are a bunch of implementations on collectors that you can use. You know, in the past, before we had toList, you had to just add collectors toList. And then you have a collect method that you can pass this to. And then the Stream API passes every element into your personal collector, and then whatever it spits out at the end is what you get back from collect. So you could plug every possible collector, or every possible terminal operation into the Stream API through a collector. I think it's every possible one. Maybe there are things that don't quite work, but that's generally speaking. Okay, and our gatherers take that same concept but apply it to intermediate operations, to the operations in the middle of a stream. So they generalize this thing to the concept of gatherers. Then gatherers, there's a utility class that has a bunch of gatherers already there that you can call if you want to. Wherever you get an instance from, you will pass to stream.gather, and then that will pass in all the elements, and the elements that the gatherer passes on or changes or whatever appear downstream. So for example, this, you would say stream of whatever, and then gather, and then this is a static import of that method gather.scan. Scan, I'm not going to go what scan does, doesn't matter that much. You have a stream, you call gather. The important part is after that you still have a stream. And then in this case, I call system out println because, I don't know, I didn't write IO println yet. I should probably. Okay, so building blocks for gatherers are 4. Only one of them is required. That is the integrator. If you've ever written a collector, some of this might seem familiar. If you've never written a collector, a lot of this might seem, why is this so complicated? There are reasons, and once you've written a gatherer or two, it becomes very natural. But initially, it's always a bit odd. So the integrator is a specific interface. And if you create a gatherer, then the gatherer has a method that returns a new integrator. So that means you don't know how many integrators there will be. Right? The Stream API basically just says, like, you tell me how to create one, and then I'll do that as often as I want. And the integrator has one method called that accepts a state that we're going to ignore for now for a moment, the element that is currently being processed, and then downstream, which is essentially just the rest of the stream pipeline that comes later. And the integrator has the task to take this, look at the state and at the element, potentially update the state. As I said, in the first examples won't have one. And then in the end be like, okay, we're going to emit 0 or more results to downstream. So it can emit 0, 1 element, more elements, doesn't matter. This integrator behaves transparently, meaning it doesn't do anything. Like it just pushes element downstream. So the gatherer has 3 generic types. And if you want to do this right, you have to write a lot of question mark extends and question mark super, which I do not put on slides on principle because that makes everything much worse. But some of the code, if you copy paste it, you would actually not work. You have to add some extends or super. This is the input type of the gatherer. So on a stream of t, you can apply this gatherer because it takes t. And this one will also emit elements t. So it will not change, like a map, right? It will not change the generic type. And this is the state of the gatherer, the type of the state. I'm going to put a question mark here because we don't have one. Sorry, we want to put a question mark here because we don't want to expose that one. You never want to expose the state type. Collectors also do this. Again, a bit weird. That's basically the reason of how generics work in Java. Ignore the middle one. This means this is what I take, this is what I emit. And what we're doing is here we're creating an integrator that has no state, which is why we're going to ignore that state with an underscore, takes a t and wants to release t, or emit t's. And so that means it gets a null, a void state, it gets a t element, and it gets a consumer of t, which is basically the downstream. I think it's a consumer. Maybe it's its own interface. But the point is, it's just the downstream that you can just push stuff to. And then you just say, okay, I don't want to do anything. I just want to take the element and push it downstream. That's like, just let's do nothing. And once we created that, we just say return gatherer off, integrator, and there goes the gatherer. And then people can put this into their stream pipeline, and again, it doesn't do anything. Okay, now let's re-implement a few things. If you do want to use gatherers, I highly recommend just re-implement map, flat map, filter. It's a really nice way to get started. You learn those operations a little bit better, and you also understand this API because you know how to do those things. So what we now want to do is we want to apply this function. So it goes from T to R, which means our gatherer goes from T to R, and we still don't need state. We just get the element in the downstream, and then we say, okay, let's first apply the function to get the new element, and then let's push the element downstream. You will also see here that push returns something that the integrator should return, namely, do we want to process more elements? Because the downstream operation might be lazy, and it might just found, like it could be find one, right? Sorry, find first. So it basically just found the element that it was looking for, so it will tell you, I don't want any further elements. And you can then transport that information upstream. Okay, good. So now we created this integrator correctly, and we're going to return it with that, and that will now implement a map function. Okay, there are 3 more building blocks. Initializer, which creates instances of state. A finisher, which takes a state in a downstream and then emits more elements. And this is the reason why a lot of things that you would want to do in the past, you can't really do. It becomes really important that if you want to create something like groups, for example, what if you have like 13 people, you want to create groups of 5? Well, you stream through, and once you hit the 6th person, or once you hit the 5th person, you're like, okay, I've gotten one group, I can emit that one group. Then you go through the next 5 people, and you're like, okay, yeah, that's fine, I'm going to emit that one. Then you walk through the last 3 people. Those are still in a group under construction, and now they're lost. Like there's never, like if you do this with the regular flat map, for example, or with a regular map, you wouldn't have a way to get like the last group out. And that's where the finish is extremely important. As soon as you do something that is like stateful, you need the initializer to create empty state basically, and then the finisher to then clean up when the stream pipeline is done and emit more elements downstream. And if you deal with state in a multi-thread operation, if you want to have an operation that works in parallel streams, then you need a combiner to combine states into one. Basically, a parallel stream pipeline will just take your stream pipeline and split it into several smaller pipelines that deal like on a portion of the data. And then each of those will build their own state. And then before the finisher can be called, which takes one state, you have to combine all the states back up again and then run the finisher once. The thing is that most operations that I could come up with that are interesting, actually all the ones that are interesting that I could come up with, only really work on sequential streams. Like things like groups, for example, groups of 5. Would you be okay if you have lots of groups of 5, but there are tons of groups of 1 to 4 people in there because the parallel stream happened to hack your long list into like sublists that don't add up to multiples of 5, and suddenly you have a bunch of 5s, and there's one group with 4 people in there. That probably doesn't sound like the kind of operation you want to have. So many operations that I feel like make sense really depend on the sequence of things, and then you cannot do parallel streams. Okay, that's why I don't have an example for the combiner, by the way. Let's create groups of fixed size. So let's say we have AC, FPS, and want to create groups of size 2. So these two, AC, and then the S alone. What we need is an initializer to create an empty group list, an integrator that puts stuff in the group and emits it when it's full, and then a finisher to emit the last incomplete group. As state, we're going to use an array list. The state always needs to be a mutable container, and array list is mutable, so that's handy. Okay, so that's the supplier. Good. Now the integrator. The integrator takes a list of T as state input, a T of element, and then spits out list of T's to the downstream. Because we got the list, the element as. Now this is just like correct implementation, add the element to the list, and then we check what's going on here. Is the list of correct size? If not, give me more elements. If yes, we create a copy of the group, clear the state, and push the group downstream and return that result. Why this is correct is not that important. Essentially is we get the state, we update it. Based on that updated state, we do things, potentially pushing something downstream. And now comes the part that we didn't have in the past without this, which is the finisher. The finisher is a by consumer, meaning it takes 2 things in and just does something with them. It takes in the list of T, the state, and the downstream. Okay, so the downstream is not just a supplier, it's its own interface. And all it does, it just creates a copy and pushes it downstream, right? In this case, depending on the semantics you want, maybe it needs to do something else. Okay, and now we create the right things. Again, like very sparse on the generics here, we create the initializer, the integrator, the finisher. Again, we do not expose the state because nobody outside of this gatherer needs to know what our state variable is. It doesn't matter, like if you expose this, all that happens is that some people on the declaration set of a gatherer might accidentally put it into a variable that has this type there, and then if that type changes, which is your implementation detail, something breaks. That's why you can just expose the question mark here. Okay, and we create these 3 instances, and then we put this into this factory method, which is gatherer of sequential. That's important. If you put there on sequential, of sequential, then this gatherer is marked as not really working with parallel streams. So if somebody has a stream pipeline where they use this gatherer and then say parallel, then parallel wouldn't do anything. Like it will still run sequentially to enforce correctness. Or at least this operation will. I think technically the stream pipeline could parallelize before or after, but I don't think in practice it does. And this is how you'd use it. Saying gatherer, then again we have like a static import probably because that looks nice. Gather groups 2, and then, you know, this is what we would get as output. The JEP goes into a lot of detail on this. Victor Klang, who created this API, has a great talk about this, teaching old streams new tricks. If you're in for a short-ish video, that's the explanation I just gave you. And this is me live coding for like, edited, it's like half an hour. I was going through a bunch of lists, a bunch of possible gatherers and just implementing them. This one is in there, and a few other ones as well. Okay, that was gatherers. Yes? So I really like this. I like stream pipelines a lot, and gatherers. Like sometimes something is missing. What I like about gatherers is that the way the API is designed, even though it's a little bit cumbersome as I just showed you, it's not obvious immediately why it works this way, but maybe I can explain a bit, by the way. The reason why it's like this is because even though the stream pipeline doesn't promise you this, I think what it does in practice is for each parallel stream, it's all like like a big chunk of this complication is just from parallelism, because potentially this could be a parallel stream, right? And so in a parallel stream, it wants to create one state instance for each parallel stream so that those state instances are not contested. Then each integrator will once again create one for each part of the stream so that they can do their thing in parallel without interacting with one another. Uses the combiner to, oh, well, it's not here, there's no combiner. It would use the combiner to put the state, to take the state pyramid into one big state at the top, and then we'll run the finisher once to get the last couple of elements out. So yeah, so that's why this API is a little bit indirect. But the cool thing about it is you're really not inclined to put any domain logic in there. Like the way it's written, it's really a lot like, okay, I need groups of whatever, or I need something like maybe you have elements that are comparable and you only want to have the largest element you've seen. So every time like a smaller element comes, you just want to ignore it. You only want to have the elements that are larger than any you've seen before. These kind of things, intuitively, they come from domain requirements, right? But you can express them in a way that are really regardless of the domain. All that you need for the thing that I just described is it needs to be comparable, or you need a comparator. And that's all, right? And then you can just reuse that. It makes it really easy to create building blocks that are very easy to test and very easy to reuse. And they make the stream pipeline, I think, a lot more viable because there were just things that you couldn't do with them. And now there are way less of those. The only thing you still can't do is really properly handle checked exceptions, I guess. I don't see that changing anytime soon. Okay, since we are on a half past now, I think we probably want to call it a day, even though I don't know. I'm here anyway.
Any questions? Now. If not, you will stay for a little while.
Yes.
I hope.
Depends on how good the PlayStation game is.
Okay.
Because like, if it's too bad, like